Hi everyone, hope you're having a great day today. We're going to go over chapter 8.1, and this entire chapter is going to be over conic sections, how to draw it, and how to determine the equation of it. So let's go over some basic conic sections that we probably already learned in algebra. So here we have a circle, and conic section basically comes from cutting these two inverted cones. So if you just slice the cone, you get a circle. If you slice it at an angle, you get an ellipse. If you keep increasing that angle, you get a parabola. If you go vertically on that cone, you get a hyperbola. So the easiest one that we're probably going to look at is the equation of a circle. So circle is defined as a set of points in a plane where it is equal distance from the center. At the center, we give the notation hk. And the distance that's equal to on that set is called the radius. So here we see the general equation for a circle with center at hk. X minus h squared plus y minus k squared equals r squared. This is nothing more than just the Pythagorean theorem. X squared plus y squared equals r squared, where the center is at the origin. I want to make a note that the x always go with the h and the k always go with the y. And the formula here is x minus h, so that your center is hk. So that means that whatever the sign here is, the opposite of it is going to be the value for your center. All right, so here we're going to write an equation. Find the center radius form of the equation of a circle with a radius of 6 and a center of -3, 4. And graph the circle and give the domain range of the relation. Okay? Let's do it over here. Let's write down the given information. The center is hk, -3 and 4, and our radius here is 6. So our formula is x minus h squared plus y minus k squared equals to r squared. We're just going to do direct substitution in here. X minus -3. So get in a good habit of just directly substituting whatever h value in first, and then you can simplify this to be x plus 3 afterward. So you don't make that common mistake. So sometime when you plug it in, you're just going to write x minus 3 instead of x minus a -3. So be careful with that. That's a very common mistake. I plug in k equals 4 and r equals 6. Now let's simplify this. And now this is our equation. Okay, so let's graph this. So whenever you're graphing, it's important to have 5 reference points like we always do. So our first reference point is going to be the center, which is at -3, 4. Now from there, I'm going to count upward 6 units because that's my radius. 1, 2, 3, 4, 5, 6. Then going to the right, since I already have 3 here. 1, 2, 3. Going down. Then going to the left. So here's 3 already. 4, 5, 6, 7, 8, 9. So somewhere right here. So you see here, we have 5 reference points, and now we can graph it. Try my best to do a circle, but circles are hard to draw. Okay, somewhere over here. My scale is a little bit off here, but you get the idea. All right, so we have 5 reference points. So my hk, -3 and 4. Now, in order to determine the domain range, all we have to do is get the values of these points. So this is -3. So what you can do, if you don't want to graph it to find the domain range, the domain, here's the formula for it, is going to equals 2, close bracket, from the h value, we're going to subtract r, and we're going to add r. So therefore, for our example, my h value is -3. I'm going to subtract 6. -3 plus 6. And this will give me my domain. So -9, 2, 3. Similarly, for the range, I'm going to use my k value and subtract r, k plus r. So my k value here is 4 minus 6 and 4 plus 6. -2 to 10. And that's my domain range. Okay, so you don't kind of have to you don't have to memorize this. Just use common sense here, because you can basically just get the center, add and subtract r to get your domain range. Okay. Okay, find the equation of a circle with a center at the origin and a radius of 3. Now, this is fairly easy because if the center is at the origin, then that's just 0, 0. And we're just going to use this form. Now all we have to do is plug in r, and r is 3, so plug it in. You have x squared plus y squared equals 9. So nothing too hard here. Now you can use the formula I just told you to find the domain range. And since h and k is 0, you have 0 minus 3, 0 plus 3. So you see domain range of both -3 to 3. And here you can graph this fairly easy. But if you want to do it in Cartesian coordinate, you're going to have to break it up into 2 pieces, because this here in the Cartesian coordinate is not a function because it does not pass the vertical line test. You can see here this touches it twice. So therefore, we have to do it in 2 pieces. So here we have the blue one, upper half, and then the bottom half. So each one of these individually is a function, but together they are not. So you can see here we have a plus minus. So up here would be positive 9 minus x squared, and the bottom here would be negative 9 minus x squared. And this negative is nothing more than the reflection of this semicircle up here. All right, let's see part B. Do we have a part B here? Okay. So here we look at the general form of the equation of a circle. Now, we're going to go over a lot more than this. We're going to go over ellipse, hyperbola, parabola. So we're going to see in standard form how to recognize that this is going to be equation of a circle. Okay. All right. So here we recognize that the x squared and the y squared are both have coefficient of 1. So in order to spot to see if an equation in general form is a circle, first you check to see if x squared and y is also being squared, and you check to see if the coefficient of x and y are both positive 1. Okay, so note both x and y are squared, and its coefficient is a 1. A positive 1, not negative 1. All right, so that means that what I can have is a circle, a point, or it's empty. Let me show you which scenario will give you a circle. So if you have x squared plus y squared is equals to a number, and that number is greater than 0, then you have a circle. If you have x squared plus y is equal to 0, then you have, let's see, equal to 0. That means you have a point. And if you have x squared plus y squared is equal to a negative number, then you have a empty set, or basically no solution. And this is not just x squared plus y squared. It can be in the general form, x minus h squared plus y minus k squared equals to these 3 scenarios. Okay. All right, so determine whether each equation has a circle, is a circle or not, and then sketch this graph. Okay? So here what we're going to learn is completing the square. So here is how to convert standard form to graphing form. So standard form is where you have x squared plus y squared plus dx plus e. Is it c? Did they use c or d? Yeah, dxey plus f equals 0. All right, this is standard form. In graphing form, that's the x minus h squared plus y minus k squared equals r squared. If we put it in this form, we're going to know what the radius is, and we're going to know what is the center is. So this one is the one that we're going to use in order to sketch. So in order to go from here to here, we have to be able to complete the square. So let's go over that. All right, so they give us here an equation in standard form. So what we're going to do, step 1, we're going to group x and y together and bring constant to other side. All right, so let's do that. So group x and y together. So here we have all x's, here we have all the y's, and then this is a constant. I'll move it to the other side. Okay, so that's my first group. My second group, bring it to the other side, so it becomes negative 25. Okay, so step 2, complete the square. Okay, by adding b over 2 square to both sides. Okay, so what is b? So a quadratic is ax squared plus bx plus c equals 0. So this is a quadratic equation. The b I'm talking about is here. Okay, let's use same capital letters. So there's 2 of them, one for the x, one for the y. And we're going to do that for both of them. So the b here for the x is negative 6. So negative 6 divided by 2 square. Okay, negative 6 over 2, that's negative 3. Negative 3 squared is 9. I'm going to add 9 here. So in order for this equation to be balanced, I need to add it to both sides. All right, so now I'm going to do the same thing for the b value for y. So here's the b value for y, 10 over 2 squared. 10 over 2 is 5, 5 squared is 25. So I'm going to add 25 to both sides. Now, step 3. We write a perfect squared trinomial and simplify. Okay. So what we did here is completing the square. Now, what that does is that we created a third term that allow us to rewrite this trinomial as a perfect square. What I mean is, now I can rewrite x squared minus 6x plus 9 as x minus 3 squared. Now, how did I get there? Well, the b value, I take half of that. So the formula to rewrite this is x plus b squared. My b value is negative 6. So negative 6 divided by 2, oops, forgot the 2. Divided by 2 is going to equal to negative 3. Okay? Now I can FOIL this out to show you that it's exactly the same thing. All right, so you can see here that we get back the same thing. Okay, so this is now my first perfect square trinomial. Do the same thing for y. Y plus 5 squared. Okay. On the other side, these two negative and positive 25 cancel. I get 9. All right, so now last step here is put everything together. X minus 3 squared plus y plus 5 squared equals to 9. And there's my equation. The center is at k, so 3, negative 5. And my radius is the square root of this, which is 3. Can I answer any questions? Do we have any questions?
I'm good.
Okay, so here we graph this. 3, negative 5. All our points, reference points here. 1, 2, 3, 4. And you notice that all of this have a measurement of 3 for radius. And here's our center for the 5th point. Okay, second example. Give you guys some time to try this. All right, go ahead and try to complete the square. You can work somewhere out here if you like. All right, we done?
I have an answer.
Okay, what you get?
I got x plus 5 squared plus y minus 2 squared equals negative 4.
Yes, no, negative 4. That's correct.
Once again,
So,
even if the r value is negative, right, it doesn't matter because it's a circle, so like all the radius will be a magnitude of 4.
no. I explained this to you earlier. Okay, So we are not in polar coordinate. This is rectangular coordinate.
Oh,
The
yeah.
r here have to be positive. So
Okay.
I told you before over here, right here, if I have an equation, a number greater than 0, I have a circle. If it equals to 0, I have a point. If it's negative, you have the empty set.
Yeah.
So
Okay.
what we got there is an r equals a negative, and this is not in not in polar coordinate. So the negative r here does not exist. Negative r in polar coordinates is okay, but negative r in Cartesian coordinate is not.
Okay.
Therefore, this graph contains no point, so it's no solution or the empty set.
And I'm gonna have to just hammer that in. Thank you. Thank you again.
Mhm.
Contains no solution. Is that true only in, okay, so we know that's true in rectangular, um, in the Cartesian. Does the negative 4 though does exist. R squared equals negative 4 does exist in the complex plane though, right?
Yeah. But then you
Okay.
talk about complex plane. You can't sketch a circle in the Cartesian coordinate because that's not the Cartesian coordinate.
Got it, yeah.
Yeah.
All right.
All right, let's try this one over here. Why did you get it? The last problem.
X squared.
Okay. Try it again.
Hey, so professor, because of the coefficients of x squared and y squared are not 1, we have to make it 1, right?
You can do that later. Yes.
Okay.
So when you are completing the square, you have to factor that one out. Yeah. So when you're grouping them together, you have to factor it out.
And when we factor it out from the x binomial and the y binomial, we also have to account for that on the right side of the equation, right?
Sorry, say that again.
So I have the first group I have 2x squared minus 6x. The second group I have 2y squared plus 10y. I factor out the 2. I got 2 to the amount of x squared minus 3x and 2 times the amount of y squared plus 5y. As I factored those out on the left side of the equation, does that mean I have to account for it somehow on the right side of the equation by dividing it by 2?
No. If you're factoring out, that has nothing to do with the right side.
Okay, thank you.
Yes. Now, when you are adding numbers on both sides, that 2 out there does affect it.
Mm,
Yes.
okay.
Be careful with that. Yeah.
Okay, Professor. So when you want the final answer in the graphing form, you want us to keep the coefficients in front of the x and y, or do you want to
No,
put that
that
out?
needs to be gone.
That needs to
So
be done.
basically, the general form, the graphing form, there should be no coefficient in front of the x or y. Everything is brought to the other side so that we can find out what the radius is equal to. Okay?
Right.
So let's look. All right, so our first step is to group them together and bring the constant to the other side. And then, so let me write it out here. Let me just work it out so you can show every step here. Okay, so our first step was to group the x and y together. So there's all the x, all the y. Okay, so now we have to factor out the coefficient of x squared and y squared. So here we're going to take out 2. This would change this to a negative 3x. Same thing here. Okay. All right, so now my b value is actually negative 3. So I'm going to take half of that and square it. So half of that, 3/2, and then square it. However, I do not add this to the other side. The reason why that is because I did not add 9/4, but in fact, I actually added 9/4 times 2. So now I have to take 2 times 3/2 squared is 9/4, and this is equals to 9/2. You can just reduce that, right? Okay, so now I have to add 9/2 on the right side. Same thing here. Take half of b and then square it. That gives me 25 over 4. Then multiply it with the number I factored out. So we have 25 over 2. So add 25 over 2 over here. Okay, so now I need to rewrite everything. Okay? All right, so it's x plus b over 2. So b here is negative 3. So negative 3 over 2 square. And then this 2, bring it down. Same thing over here. Y minus 5/2 square equal. All right, so let's add all these together. I'll have a denominator of 2, so let's change this 1 to a 2 as well. So 2 plus 9 plus 25. Okay, that's 27 plus 9, that's 36 over 2. Okay, all right, so now I need to get rid of this 2 here. To do that, I'm going to divide both sides by 2. Divide both sides by 2, or multiply by 1/2. Same thing. So now these 2 will cancel. Simplify this. 36 over 2, that's 9. All right, so here's my HK. My center, 3/2 and 5/2. And my radius, square root of this, is 3.
Hey,
And you can see,
Professor. I don't understand how you got the y minus 5/2 over 2. I got y plus 5/2 over 2.
oh, yes, you're correct. Yeah, this is positive here. So.
Oh, okay, cool.
Yeah, so that becomes negative. Okay,
36 times 1/2.
3/2, negative 5/2.
Okay, so really quickly, when you're completing the square, right? In this case it was x squared minus 3x plus 9/2, or was it? It was technically negative 3 over 2 squared, and then eventually you had to multiply 2 in order to add it to the other side, right?
Yes. Yeah.
Okay, but then within the bracket itself, right, before we actually factor out as x minus 3 half squared, it was still x squared minus 3x plus. How would you write it? Would you prefer we write it negative 3 over 2 squared, or would you prefer that
No,
we simplify it?
you should simplify it and write it as 9/2.
It would be 9/4 first, and then you multiply it by 2. So within the
Yes, yes,
bracket, it would be
9/4. Yeah,
9/4.
yeah. That
Okay,
would be
I
9/4.
see.
Yeah.
I see.
Yeah, so the reason why I kind of like to leave it like this is because this number right here is the same as this one. Because it's b over 2.
Got it.
Like over here, same thing, 5/2. This is 5/2.
Yeah.
All right.
Okay. Before we continue, I just kind of want to know, where are we going with this? Why is this being taught in pre-calculus right now?
Because when we go to calculus, we're going to not use these specifically, but we're going to look more in depth about parabola and hyperbola, more specifically in the three-dimensional space.
Oh, okay.
Yeah. So in order to do that, you need to learn how to do it in two-dimensional first, because when we have three-dimensional, we're gonna have a basically a saddle that looks in three-dimensional that looks something like this.
Okay.
So one goes in this direction, and the other one goes in this direction. Yeah. So it's very hard for me to show you that in two-dimensional. It's kind of hard to draw. So, but yeah. And then we also deal with surface area of a curve, and in doing that, we're going to need to know how to complete the squares and deal with circles and ellipses like this, because you're going to have basically an axis, and you want to basically revolve something around this axis to create a shape, and that deals with these type of shapes here. This is the most basic shape. All right, so parabola is actually widely used in a lot of electronics, and anything that deal with communications and radar and sonar deal with parabolic shape. So what you're used to seeing is y is equals 2ax squared plus bx plus c. That's in standard form. Or y equals ax minus h squared plus k. This is called graphing form for a parabola. Well, we're going to look at a different way to understand parabola, because here it's only understanding parabola in the sense that it opens up or down. But we're going to look at parabola where it opens left or right. And we're going to see how can we determine whether we have one of these scenarios or not. And before college algebra, we only look at parabola where we have the vertex and the a value. That's it. Here we're going to look at how parabola is actually defined, so we have a better understanding of it. So a parabola is actually a set of points where it is equal distance from some fixed point and a fixed line. This is actually quite interesting. Now we have a focus here, and that focus is basically the equal distance to all of these points on this parabola as it is to the directrix. So what do I mean by that? So let's look at a picture. Where is that picture? Okay. I guess we can just use this picture. So what this definition mean is that if I pick any random point, let's pick this one right here. What this means is that the distance from here to the focus is exactly the same as from here down to the directrix. So where this is perpendicular to it. So this distance right here is the same thing as this distance. So I can put a line right here to denote that. Okay. Of course, that means that the focus to the vertex is the same distance from the vertex to the directrix. And any other point, for example, this point right here. That point from here to here is the same thing as from here straight down to the directrix. Okay, so that's what it means here. So that's how we get all these points right here. So you should remember the relationship of these of the focus and the directrix. The distance right here, the distance right here, they are the same. And also the axis of symmetry goes through both of those points, the focus and the vertex. So if we understand the axis of symmetry, we can understand whether it opens up or down as opposed to left or right. So if our axis of symmetry is horizontal, that means it has to open left or right. Now look at the position of the focus. The position of the focus is inside the parabola. Inside means that it is inside of this curve. So the focus would be here inside this parabola, and the focus would be here inside here. Similarly, if it's open downward, then focus would be there, focus would be there. Okay? All right, let's look at the equation. So the parabola with the focus 0c and the directrix of y equals -c has an equation of x squared equals 4cy. This 4 right here is a constant. Okay, this 4 does not change, so it would be 4 for every single equation. All right, so the c value is going to be the distance from our vertex to here. And of course, that's the same distance in the opposite direction to go to my directrix. Okay, now if x is square, that means it's going to open up or down. How do we determine if it opened up or down? We look at the c value. If it opens upward, if c is positive, open downward if c is negative. Now remember, when they give you an equation, the 4 and the c will be multiplied together. So you have to divide whatever number that is by 4 to figure out your c. Right? Similarly, when we have y squared is equal to 4cx. So the y is being square, so that means that it's going to open left or right. Okay? And similarly to the other one, open right if it's positive, open left if c is negative.
Professor, to reiterate, when you're saying x squared equals 4cy, c is the distance from the vertex to both the focal point and the directrix?
Yes.
Okay, thank you.
And same here. So c is the distance from the vertex to focus or from the vertex to the directrix. Now, anytime that you go into the directrix, that line needs to be perpendicular. Okay. Okay, so let's look at this. We have x squared is equals to 8y. So let's remember that we have x squared equals to 4cy. So you see this 8 right here. That means that 4c is equals to 8. So and divide both sides by 4 to get c is equal to 2. C is positive, so that means it's going to open upward. Because we're going to look at two things. We're going to look at x as being square, c is positive, so therefore we're going to open upward. So that's going to give us our location of the directrix and the focus. Since we know that this is the vertex is at the origin, we just have to go up 2 and down 2 to determine our location of the focus and the directrix. All right, so let's do y squared here. You want to take some time and try this first? Go ahead and sketch this.
In that last one, Professor, like x squared equals 8y, does that parabola always go through the origin?
Yes. Now remember, we don't have h and k here, right? In the general formula, it's actually x minus h squared equals to 4cy minus k.
Got it. And in this case, h and k would be both 0.
Yes, exactly. And notice here, this is not squared. Y minus k is not squared. Just y minus k.
Got it.
Okay. So whichever one is being square, that is going to be the one that you're going to see opens up or down, left, right.
Okay, thank you. And then with y, right, the constant is still always 4c.
Yeah, it's always 4. X, yeah, doesn't matter if it's X or Y. Parabola is always 4c times whatever the other variable is.
And for the y-squared equation, did you want us to sketch it out, or what kind of answer did you expect, sir?
So sketch it and then label everything. So we want to find out the focus, directrix, vertex, and axis of symmetry for the parabola. So basically, just sketch it and label everything.
Okay, and were there any specific variables that affected the axis of symmetry, or do I just, because of this equation, do I
Once
just put
you
the axis?
figure out what is the vertex
Huh?
and the direction that it opens in, then you can
Okay.
determine your axis of symmetry.
So what is the vertex and the direction opens in?
So the direction that it opens in is easy to find if you know what the focus is. And you
Yes.
can find that out based on your C value. All right, so let's go over the steps, right? So to inspect everything, okay? So first of all, step 1, let's determine, is it open up or down, or left or right?
Well, in this case, it can't be up or down because it's y.
Exactly. So if it's x squared of up or down, y squared of left or right, right? So that's only step 1. So we know that it's going to be open left or right. We don't know which one yet.
Mm-hmm.
So step 2, find C by setting for C equals to the number here. Okay, so divide by 4, C is equals to -7.
Okay. Now this initial c value, that's where the focal point is, right?
C, yes. So now this C value by itself, you cannot use it by itself in order to sketch it. You have to use it in conjunction with what you found in step 1. So let's plot it, right? I know that the vertex is at the center. If it's not, you can find out by looking at the full formula, y minus k and x minus h, right?
Okay.
Okay. So here, h and k are both 0. So we know the vertex is at 0, 0. Now we know that it's open left or right. Now C is negative, so that means it's going to open left. So I need to go to the left 7. Okay, but there's also the hint here, negative means going to the left or going down, depends on if you open up, down, left or right. So here we're going to go to the left 7. Let's just say that right there is 7. So from here, you should know your axis of symmetry is the x-axis.
Okay, so that's pretty cool. The axis of symmetry is the same axis where the focal point and the vertex lies on.
Yeah, that's the definition. Yeah, that's literally what the definition is.
Is
So,
that what happens when we deal with multi-dimensional graphing, like more than 2 dimensions? Where would the axis of symmetry? I mean, the definition should still be the same, right? Wherever the plane or whatever plane those
yeah,
two
the
points lie
plane
on.
is going to cut the shape. Yeah, instead of a line.
Okay, I get it.
Yeah, if you have like a sphere and you use a knife to cut it, like right in the middle, then you have the axis of symmetry there. But the sphere also have infinitely many axes of symmetry.
Got it. This is the entire plane where it was cut.
No, you can have different plane to cut the sphere to have axis of symmetry.
Okay, so there's directrix.
Alrighty, so here we have our parabola. So we have our vertex here, our focus here, our directrix, and our C value. Okay, that's everything, right?
And then when we graph this out on the test, do you want us to label all 5 points of reference? 1, 2, 3, 3 points, and then the 2 C values?
So the C value here is the same. There's actually another point right here and right here. I always forget this name for some reason. But yeah. Oh no, I'm sorry, not there. It's right here and right here. So
Okay.
these, there's actually 5 reference point total. 1, 2, 3, 4, and then directrix is 5. So these 2 points right here, it helps you determine how open this is, how open this parabola is. This is it's like Italian or French name for it, but I forgot what it is. But I'll get it to you later. I don't think it's in the PowerPoint. It's in the book for sure.
I don't understand what that means. How is it like how wide the parabola is?
Yes, how wide this is. Yeah.
Okay.
So basically, to get to this value right here, so you notice there's an open left. That means that both of these points are going to have the same x value. So we're going to plug in x value in there, and we're going to have 2 different y value. Okay. So we're going to pick whatever the focus is. So the focus here is -7, 0. So I'm going to put -7 into my formula. Okay. And then we're going to have 2 different values. So for example, y squared equals -28. I'm going to plug in -7. Right. So if I solve for y, it's square root of it. I'm going to have y equals to plus or minus whatever this number is. Square root of 28 times 7. Okay. So it's going to be 7 and 2 is 14. Plus or minus 14.
Okay.
Yeah. So this point right down here is -7, -14. This one point up here is 7, 14. -7, 14. We have 5 points there.
Okay, so what I've noticed in your teaching style, sir, is that you really emphasize reference points because in a way it helps us understand things analytically. How, besides how wide the parabola is there any other importance that we need to get right now for those last 2 reference points?
So the only reason why we use these 2 reference points is because if I only give you this point, and this, how do you know to draw this? You don't. How do I know that the parabola look like that as opposed to looking like this, like open wider?
Got it.
You don't. So that's why the more reference point you get, the better the picture is going to look like. It's
Okay.
Yeah.
Okay, thank you.
Okay. And the other reason why we use these 2 points is this. See if you can figure this out. What do you see?
I see a square box.
Square. That's exactly right. So when we draw it, we should see a square. So it's visually easy to see it. So it's easier to sketch it if you kind of imagine that, oh, yeah, I'm supposed to get a square.
Professor, in my future, right, will I be doing any kind of linear transformation on these parabolas?
Um,
Because when I see squares, right, I intuit matrices immediately for some reason. It's just what I'm gearing towards.
no.
No? Okay, well I had to know. Thank you. Okay, so I guess and my next high picture, high level question is when do I need to use sine and cosine and secant and tangent in parabolas?
Let's see.
Maybe not this course, and I understand that, but like in my future. When is that going to happen, sir?
Now, you're not going to use sine cosine. Maybe you can use hyperbolic sine cosine.
Man, that sounds hard.
Which is, yes, it is. It's actually one of the hardest things. Even I hate it. Yeah. Yeah, let's not delve into that. But yeah,
Sir.
here you go. All right, so here you see it's not going to be a square. Say how this is open up. You see this one right here? How this is wider than the other one. So you're going to get, when you draw right here, so this one is wider than the first one, right? So over here, what is the point from here to here? C was -7, right? So from here to here was 14, right? From here to here was also 14. So do you see that shape again?
Yes, it's still a square.
Yeah.
So with the directrix, it will always be a square.
But do you know why that is, though?
Magic.
Magic.
Why is that, Professor? Because the distance from the vertex to the directrix and the distance from the vertex to the focal is the same length.
Yes, that's exactly right.
Yep.
Yeah, that's by definition, because it's saying that from here to here have to equals to from here to here. Well, if that's the case, then of course you can draw a square there. That's by definition. Yeah. Okay, so here we're going to look at equation. This is one of my favorite sections because it's kind of like a puzzle. You kind of got to figure stuff out and working backward. Find an equation for the parabola with focus of 2/3 and 0 and the vertex at the origin. So I always suggest you plot this out just to give you a sense of where it's going. So we're going to plot a few points, just maybe 2 points. It's going to help you. Say, so vertex is at the origin. That's my HK. Focus at 2/3 and 0. Let's say this is 2/3 and 0. All right, so now you know the axis of symmetry is going in this direction. And you also know that it's going to open up this direction. So that means that y square is positive. Your c value is also positive. So 4cy. So this, just knowing those 2 points, start you out with the equation like this. Now you got to figure out what is your c value is equal to. Well, c value is right here, 2/3 from the vertex to this point. That's 2/3. We get 4 times 2/3 times y, so you get 8/3 y.
Is that supposed to be y, sir, or is that supposed to be x?
Oh,
There,
I'm
it's
sorry.
x, right?
Yeah, that's x.
Okay.
That too.
And then the directrix will be at -2/3. How do we solve those two weird sounding Italian points, sir? It would be
This point and this
the
point, just plug it in. Plug in x equals 2/3 in here.
got it.
That's going to bug me. I'm going to go find out what those 2 points are called.
There's so many different names.
Lattice rectum. I think that's called lattice rectum. Let me see if it's in here.
Okay, I found it.
Found it?
Yeah, latus rectum. It's
Lattice
Italian.
rectum. Yeah.
Oh,
Italian name, right?
it's
Okay.
Latin actually. Wow, crazy.
Latin? Okay. One of those. Okay, so here we go. We got y squared equal 8/3 x. All right, let's try another one. Yes. Why can't I do a rectangle? I gotta be a square. All right, I want you to sketch the point over here and write the equation for me. You still there? Say something.
Yes.
Okay. All right, very good. All right, so we see that this is a vertical axis, so we know that's going to be x squared. Okay, so let's draw that to show this. So vertical axis means that my parabola have to either open up or downward. So whether it open upward or downward is dependent on our variable c. And they only give us a point, so all you have to do is plug it in. So we know that the general form is going to be x squared equals to 4cy because the vertex is at the origin. And then we plug in our x and y and solve for c. Why is this negative, my? My? Why is this negative?
Because I think I move the 4 to the right side. I think so.
No, you didn't have to move the 4 to the right side. You are dividing both sides by 48. And the c is by itself, so 4 over 48. No, you're dividing, you're not subtracting, so this should still be positive.
Okay.
Right? So okay. There we go. We got x squared is equal to positive 4 positive 112y. Okay? So x squared is equals to 1/3 x. I'm sorry, y. I keep mixing those two. Okay, so here we go. We talked about the vertex. Where is that hk? So all you have to do is remember that h go with x and k go with y. And both of them are not square. Only one of them is square. All right, so here they ask us to graph the parabola. So anytime they ask you to graph something, make sure you rewrite it in the graphing form so you know what is our c value and what is our h and k value. That will help you graph. So here we need to get the square term by itself. So I need to move this over. We have x minus 2 equals to negative 1/8 times y plus 3 squared. And we're going to move this negative 1/8 over. That gives us negative 8 here. So now we have the form that we want. Our h and k is negative 3 and 2. Now we need to solve for our c value, right? My c value is in here. So I know that for c is equal to negative 8, so c is negative 2. Now, since this is y is being square, that means it's going to open up left or right. My c value is negative, so that means it's going to open to the left. So let's try to graph this. My vertex is at negative 3, 2. So right there. And my focus is going to be 2 to the left because this is negative. Then my directress 2 to the right. There we go. So now I can find out what my other two reference points are. Now, since the distance from here to here is 4, all I have to do is go down 4. Because I know this is going to create a square box here, right? So I'm going to go up 4. So that's going to give me 6 up in here. So there goes my parabola. There you go. Here's a better picture. All right, so you can see here, I go down 4, get to negative 6, and then up 4 to get to 2. Any questions?
No questions for me, sir.
Okay. I'm going to give you some time to try this. So you only have 2 pieces of information here. You have the focus and the vertex. James, why don't you show your work and write the equation this time?
Okay. Oh, there's no square here. Oh, this is 2, 2. What is up this way? So this can be y squared equals 4c, where c is greater than 0. Okay. C is an equal 3. C equal 3. So then this is plus 5 plus 6 equals 2, 8. 2 minus, so -4. And then the direction to here is also write an equation for the parabola. So y squared so the professor, the equation,
Mm-hmm.
I don't know if it's gonna be that easy. So would the equation be y squared equals 12x?
Give me a second. I'm gonna show you the work. I'm having a hard time kind of understanding your graph here.
Did I read it wrong? Vertex is -1, 2. Focus is at 2, 2. Because the focus is right of the vertex, so it opens up to the right. Okay, yeah.
Okay, so I have C is 3. Vertex is at -1, 2. Opens up to the right, so that means that Y is square. We have 4 times C, which is 3 times, it's X minus, what's my vertex? -1, so X plus 1. And this Y right here is -2. So you should get Y minus 2 squared, 12 times X plus 1. Is that what you said?
Okay. No, I completely forgot that if given H and K, you just have to use it in the equation. It's not at the origin. Okay, yeah, so I got that wrong.
So Y minus 2 squared, 12 times X plus 1. Okay. Here. So we have to graph it. So we have to rewrite it in graphing form. Why don't you rewrite this in graphing form for me? Ma, you there?
Yes.
Can you show the work for completing the square?
Okay.
Are you done, Mai? Or are you stuck somewhere?
I'm stuck in there, and I don't know how to do more.
Okay, that's fine. All right, so what you did is you took out -2. So now you need to complete the square. You need to take this b value right here. You can take half of that, and then you're going to square it. Okay? So if you take half of that, you're going to have -2 divided by 2. It's going to be -1, and you're going to square it, so you get +1.
Oh.
So what you need to do with this +1 is to multiply with this number outside, and then whatever that number is, okay? So what you just did here is you actually added a -2. So that means we need to subtract 2 on the other side as well. Right? Because if you distribute this, right, this times this is a -2, so you need to do the same thing on this side. Okay?
Okay.
So now we can rewrite this as -2y minus b divided by 2, which is just -1 square. And then combine these two, you have x plus 1. Is that okay so far?
Okay.
And then we need to get the y by itself. Okay? So we need to divide both sides by -2 or multiply by -1/2. So now we can rewrite it as y minus 1 squared equals -1/2 x plus 1. So here in this form, give us our h and k to be +1 and -1. Now we define our c value. My c value is equals to, remember that we have 4c equals to whatever number this is. Divide both sides by 4. C is -1/8. So now we can graph this. Okay, so our HK 1, -1 right here. And my directrix is, I messed up somewhere. It's -1/8, right? Yeah, that's fine. Yeah, so -1/8. So here they just use some reference points. Use whole numbers to do it, but instead of our regular 5 reference points. Okay. All right. Let's look at some application. So this is how all TV dish are made. The location of the focus is basically where they put the signal, and then when you have the signal sent out this way, so it doesn't matter how you hit it, it's actually going to go upward like this. Okay, and this is how a lot of heat shield. If you look at those heat fan that have the parabolic shape, so the heat will radiate off of this, and it will be in direction like this. Sorry, like this.
So we'll always be going straight up at that same angle, no matter where it bounces off the curve of that parabola.
No, so this this example right here, this one is receiving the signal because it doesn't matter where you hit from out here, it doesn't matter what angle it's hitting, it's always going straight to the focus.
Oh, okay.
Yes, that's where it receives its signal. So what are we trying to find here?
Professor,
Determine.
I'm surprised we're not trying to find any kind of angle theta in this kind of word problem. I feel like isn't that the point of this class? Find theta.
It was, but no, not anymore. In this section, we don't deal with any trig in here. It's all just stuff. This
Okay.
is all algebra stuff
Yes, sir.
and understanding concepts. And this is more like preparing you for calculus. Okay, so I'll go ahead and write an equation. Yeah, so write an equation for this. What do you need to know before you write an equation for this? More likely, what do you need to assume?
I can assume that half of the distance of the diameter, so 105 feet, would be the same thing as distance from the focus to the directrix. Would that be wrong?
Say that again.
So half of 210 feet, so 105 feet, would be the same thing as the distance from the focus to the directrix. And therefore, I can find my C value from there.
Why do you assume that?
Because I can make a square.
That's not true. Remember those points are? It's actually in line with a focus, not some random point there.
Oh, I see.
Mm-hmm.
Can I assume that twice the amount of 32 feet would be my C value? I can't, right?
Why?
Oh, why can't I do that?
So now this is a little bit harder than you think, huh?
Yeah.
Why? Any ideas? You have to make one assumption about the vertex. Where is the vertex?
You have to assume that the vertex is directly underneath the focus.
Yeah. Well, I mean, we already know this, so we know that it opens up. Now, my question to you is that where is my x-axis?
The s-axis would be the dashed line, right?
Why? It could be, but you're making this problem harder. What is
Okay.
the easiest vertex?
I see
Where's
what you mean. The
vertex?
vertex would be at the origin then, 0, 0.
Origin. Exactly. So which is right here, right? So we have to
Okay.
assume that, or we don't have to assume, we can write our equation such that the vertex is at the origin. That would give us this point right here and this point right here. Okay? Now, Do I know what are these 2 points equal to? Now the problem would be easier if you figure that out. You said it earlier, that's half the distance, so this is 105. So if this is the origin, this is positive 105, this is negative 105. So this is x value is negative 105, the y value is what?
32.
32. So we have 2 points, right? Negative 105 and 32, and positive 105 and 32. Well, that's 2 points on this parabola. How will that help us? What else do we know about the general equation? What is the general equation? I did this problem earlier. So we know the general form is x squared is equals to 4cy. Why do I know that?
Because we know that it is a down parabola, so it's x squared. We also know that it's pointing up, so that c is greater than 0.
Mm-hmm. All right, so now can you find out what the c value is equal to? That's the only missing variable here. How can I find c?
Is it as easy as just plug and chug?
Exactly. Plug and chug. Plug in x, 105 squared equals to 4 times c times 32. So c is equal to 105 squared over 4 times 32. What is that? 11,025 divided by 128. Whatever that decimal is.
Like 86.132. 133 if you round it.
About 86.1, okay. But to be exact, we should always leave it as a fraction here. So our equation is then x squared equals 2,11025 divided by 32. Okay, it's 32 because there was a 4 here that we simplified. Okay. All right, and y. So that's my equation. And I think that's it. Here we go. All right, the receiver must be placed at the focus of the parabola. How far from the vertex of the parabolic dish should the receiver be located? Well, we got about 86.1, so 0, 86.1. Does that make sense?
Okay, that does. So I guess the fundamental assumption is that we should assume the vertex is at the origin to make it easy.
Mm-hmm.
And then from there, because we're given that diameter, right, we can assume 2 points, giving us x and y coordinates on the parabola.
Mm-hmm.
And then from there, with the x and y coordinates, we can plug and chug, giving us a c value.
Yes. Again, we don't call that the diameter, by the way.
Oh. Okay.
Okay, that's it for today.
Really quickly question, did we not get homework 11.7 counted towards our grade?
Let me look then. Because did it not change your grade when you are working on it?
Initially it did, but then I went to review my grade, and it says it's now omitted by instructor.
Okay, let me look at it then. Thanks for letting me know. But other than that, do you have any other question or concern? 7.7. Here we go. Done. Okay, it should be updated by now. Anything else?
Do we need to review our syllabus to confirm the test dates for this month? Because I know it's a Thanksgiving month.
So the last day for this class is actually on the 16th. And so our final week starts on Thursday the 10th. And so that means that your next test is going to start from December 4th to the 6th. Is that what I wrote on the syllabus?
That's different, sir. So I have on my syllabus exam or the non-final is on November 20 to 22nd.
Ah, okay. So yeah, I think I scheduled that because I wanted to do it before the Thanksgiving break. But since I think our final is actually a week later than normal, I think we should do it after Thanksgiving break, the 4th to the 6th.
Okay, so December 4th through the 6th.
Yeah.
Thank you. 4th through 6th. And then I had it written down that our final, that you would allow us to take the final starting on December 9th. Has that changed?
No, that did not change. Let's see how much. I think it should be the 10th, not the 9th.
10th, okay.
Yeah.
And then for our final, and because it's so, because it's comprehensive, right? Are we still going to do it in 3 hours, or is it going to be a longer, or is it going to be a longer time test, sir?
I'll give you 4 hours.
4 hours. And are we expecting around 50 questions then, or?
No. It'll be around 30. It'll be the same amount, about 30 to 35. Yeah, it's not going to be like twice as much.
Okay. And are we going to add any more sections to our exam 4? So I have sections 8.1 through 8.4, and then sections 12.1 through 12.5. Is that going to be the same, or are we going to add or detract?
We are most likely going to take away from that, not add more to that.
Okay. Got it. And so what's this month going to look like with that Thanksgiving week off, sir? Like, what do you expect from us in terms of
I'm
that
going
week?
to open up all the homework. So you need to get if some of you are not doing homework, or your homework grades are low. Now remember that the homework grade is like a test grade. So if you have a low test grade, you can balance it out with like an A on your homework. It should be 100 on your thing. So that matters a lot. So if you increase your homework grade by a letter grade, you can probably raise your test score by a lot if you have a low test score. So
Got it, sir. And
yeah.
I know what you said earlier in the semester, but I just want to push your buttons today. Will you be offering any kind of extra credit or anything for the class this semester, sir?
The extra credit I'll give 10 points per exam.
Thank you,
Okay.
sir. And what do we need to do to earn that extra credit, sir?
Attend lecture.
Oh, that's just so hard to do, sir. I don't know if I can continue doing this.
No, I'm kidding. I'll give it to everyone. So you don't have to do anything.
Okay, thank you, sir. And I'll get my test review in before Monday at midnight.
Yeah. All right.
Thank you for the lecture. Have a good election day.
Great. You too. Take care. Bye bye.